All right, let's do another one of the hard ones from the second part of 9.3 here. Okay, so the cable is connected 6 meters from the left side. So that point is 6 meters, right? Makes an angle of 39 degrees, whoop. With a 10-meter long beam, so this guy's at 10 meters, right? Find the tension in the cable, horizontal, vertical components of the force exerted by the wall. Okay, so let's draw our forces, right? On this point here, we've got a upward force that I'm going to call wall in the y direction, a force to the right, which I will imaginatively call wall in the x direction. Okay, we've got a force acting along this cable. Hard to draw, hard to draw. If you can imagine that I just drew a straight line along that cable, that would help a lot. All right, and then of course that has components here and here, right? The vertical component there is t sine theta, right? So sine of, 39, and that's going to be in the y direction, right? And then we've got t cos theta, and that's in the x direction, right? All right, let's see. Okay, so those are our forces. Then we also have the force of gravity acting here, right? So we've got 8 times g, that's acting at 10 meters. Let's see, we've got, it's a 10-meter long beam. Don't we have the force of gravity on the beam, right? That's going to act down. So that's 11g, right? And that is at, how far? 5 meters from the left side, right? T is at 6 meters from the left side. And of course, the wall is 0 meters from the left side, right? So both of these are at 0 meters. Okay, so let's set up our expression for torque. I like to set that one up first. Okay, so we've got 0 times whatever the wall exerts. We don't care x or y because it's times 0. Although Wx clearly does not exert a torque. Let's see. Then we've got, let's see, in the positive camp, this would be a positive, the weight of this would be a positive torque. So positive 5 meters, right, times 11g, right? And then we've got the tension, right? So minus 6 meters, right? Times, let's see, t sine of 39, right? So that's going to be an anti-clockwise torque. This force is going to tend to rotate it that way. The weight of the beam will tend to rotate it clockwise. Okay, so this one's positive because it rotates the beam clockwise. The tension in the cable is anti-clockwise, right? And then let's go all the way out here. This guy here is 10 meters out, right? Whoops. So I'm sorry. That's going to be plus 10 meters times 8g. Okay. So here are all our torques. We've got the wall, which is no torque at all because it's acting at the hinge. We've got the force of gravity, which is 5 meters times 11 times 9.81. Right, so g in this thing is 9.81. We've got the force of this cable, right, which is 6 meters times t times the sine of 39. And then we've got the torque exerted by the little sign hanging at the end there, right? So 10 meters is how far it is away times 8g, that's the force, 8 times 9.81. And then that equals 0. Okay. The weights are positive because they tend to torque the thing clockwise. This is anti-clockwise. This is clockwise. That's what the signs are for, right? This can be solved for t. So let's do that. Okay. So 5 times 11 times 9.81 plus 10 times 8 times 9.81. I got an answer. I'm going to divide that by 6, divide by sine of 39, and voila. I should have the answer. Yeah, okay, there we go. So I'm getting that t is 358.735. which I will store, that's newtons. I will store that in the variable t. All right, let's set up our x equation. In our x direction, we have only the wall in the x direction, minus t cos theta, so cos 39, sorry, that's got to be 0, right? So I believe it stands to reason that wx is t cos 39. So let's do that. I'm going to go times cosine of 39. I get 272.57. Now, if you missed what I did here, I just plugged this guy into there. I went 350.735, and I did times the cosine of 39. Make sure you are not in radians. Otherwise, you'll get sort of interesting random answers. Okay, so there's that. We've got that. And now let's figure out the y. This is kind of a little bit, the y equation is a little bit more salacious. A lot more going on there. Okay, so we've got the wall in the y direction, minus, 11g, plus this side here, right? The vertical side, this little component right there, is opposite that angle, so therefore it is t sine 39. That's what I was trying to write here. Okay, so plus t sine 39. And then minus 8g is 0. All right, so let's see. I believe that wy would be this plus this minus this, right? We just move that to the other side. So let's do our maths here. Okay. I am doing 19 times 9.81. That would be 11 plus 8, right? Minus t, so I go alpha t, or you could just type in your 350.735, right? Times sine of 39. All right, are we ready for this? Ooh, it's kind of spicy here, right? wy ends up being negative 34.3 newtons, right? So here's what's going on here, right? This cable's attached here. This is actually the pivot point, right? If we unleashed it here, this thing would actually torque the thing around, and this would move up as a result of the weight of this pivoting around this point. So that this wall actually has to exert a downward force, right? The force that this wall exerts is small, but downward, right? Ta-da. That's kind of interesting. Interessante. All right.